Hello viewers, welcome in Asmi's Chemistry Academy. We have started to learn about the aldehyde, ketone and carboxylic acid. Almost we have completed the introductory part of that. Second one is classification, nomenclature, isomerism and one preparation reaction we have seen in the previous video. I hope everyone has subscribed my channel, like my videos and see my videos, and whatever comments you want to share, you can share in the comment box. Let us start the second part of the preparation reaction. In that we are going to see the second preparation reaction from hydrocarbons. As we know about the hydrocarbons, when carbon-carbon single bond is given, then it is alkane, carbon-carbon double bond, alkene, and carbon-carbon triple bond, then it is alkyne. Now in hydrocarbons, second reaction from hydrocarbons, in these two reactions we are going to see, and from alkene and alkyne we are going to prepare the aldehyde and ketone. First reaction in that, by ozonolysis. Ozonolysis of alkene. Now what is mean by ozonolysis? Ozonolysis means addition of ozone. Okay, ozone formula, molecular formula, it is O3, and when the addition of ozone it takes place on alkene, I will write just general molecular formula of any alkene. You can write these two valency either with the hydrogen, or else you can write it the methyl, ethyl or alkyl group. When the ozone is added on the alkene, at that time the cleavage of carbon-carbon double bond will takes place. Now see here, carbon-carbon double bond, it will break, and addition of ozone, that is 3 oxygen molecule will takes place like this. But this reaction is not too simple to takes place. Alkene reacts with ozone and it forms the ozonide. It requires the catalyst, that is carbon tetrachloride. In presence of CCl4, alkene reacts with ozone, it forms ozonide. You can see here the carbon-carbon double bond, it is broke, and addition of 3 oxygen, it is taken place like this. But the remaining 2 valency of each carbon atom, it will be as it is. Okay. Further, this ozonide decomposes with the zinc and water molecule. Or you can say that this ozonide undergoes hydrolysis in presence of zinc, then it forms corresponding aldehyde and corresponding ketone. See here, when it reacts with the zinc, then this oxygen and this oxygen bond will break and it forms C, this 2 valency, and when these 2 bonds are broke, it will form the partial double bond in between carbon and oxygen, then it forms, see here, this 2 valency it will be as it is, and by the help of these 2 bond it forms the partial double bond, then it forms C double bond O. Another C, this 2 valency carbon, this 2 valency. Now this carbon atom and oxygen, when it break these 2 bonds, then it forms the partial double bond on this carbon and oxygen atom. So again it will form the C double bond O, this one, and this 2 valency will remain as it is. Okay. Now what is remaining over here? This oxygen is remaining and this zinc, and it forms the byproduct, that is zinc oxide. Okay. This is the general reaction. Let us see the example of this. Either this 2 valency you can satisfy it with the hydrogen atom or any alkyl group you can take. Suppose I will take this example. What is the name of this? You have to select the longest continuous chain of carbon atom. 1, 2, 3 and 4. 4 carbon atoms are there, so it is bute. Okay. And on which carbon atom double bond is given? In between second and third. We have started number from this side, so bute 2 in. Okay. When bute 2 in reacts with ozone, in presence of CCl4, then it forms ozonide. See, I have written this remaining part as it is, just in between two carbon atom addition of ozone takes place. Now further, this ozonide undergoes hydrolysis in presence of zinc, then it forms, see here, CH3 CH double bond O, CH3 CH double bond O. It means that two acetaldehyde molecule it will form. So directly I will write here CH3 C double bond OH, and remaining this oxygen and zinc, it will form the byproduct, that is zinc oxide, and the name of this, it is acetaldehyde. This is the common name, and what is the IUPAC name? That is ethanol, because here two carbon atoms are given, so it is ethanol. The second preparation reaction from hydrocarbons, we can prepare the aldehyde and ketone by alkynes also, but the reaction is, second reaction, by hydration of alkyne. Now what is mean by hydration? Hydration means addition of water molecule, and the addition of water molecule, it takes place on the alkyne, and then it forms the addition product, and further it undergoes tautomerism, it forms the aldehyde and ketone. Let us see how it forms the aldehyde and ketone. C triple bond C, any alkyne we can take it here. This one valency of each carbon atom, it can be satisfied by the hydrogen atom, or else you can take the methyl group. When this alkene undergoes hydration, hydration means addition of water molecule, and this addition it will takes place in presence of sulfuric acid and mercuric sulfate. Here we have to take 1% of mercuric sulfate and 40% of sulfuric acid, then it forms the addition product CH2 double bond CHOH. This is the addition product. Further, this addition product undergoes tautomerism. What is meant by tautomerism? Tautomerism means reshufflement of the proton. Proton means hydrogen atom. Then it forms the corresponding aldehyde. See here, how many carbon atoms we have taken? 2 carbon atoms, same number of carbon atoms we have got it. Just the addition of water molecule, we can prepare aldehyde, or else we can prepare the ketone with the help of alkyne, and this is the hydrocarbons. Let us see one example of this. Suppose this one valency I have satisfied of the carbon atom with the hydrogen triple bond CCH3, okay, and this remaining second valency I have taken here methyl group, plus H2O in presence of same reagent, then it forms CH2 double bond CH3OH, okay. By breaking of this double bond, this hydrogen atom will add on this carbon atom, and this is the tautomerism. What it will form? This hydrogen will go to this carbon atom, then it will be CH3 CH3, and in between this carbon and oxygen it will form the double bond, and this is the ketone. See here, in the first previous example we have formed the aldehyde, and in this example we have formed the ketone, okay. By the help of this reaction, hydration of alkyne, we can prepare the aldehyde and ketone too. Now let us see the third preparation reaction. From other method we can prepare the aldehyde and ketone. Now third reaction, that is Rosenmund reaction. Now in this reduction is takes place. What is mean by reduction? Reduction means addition of hydrogen atom. But the addition of hydrogen, it is takes place on what? The addition of hydrogen atom, it is takes place on acid chloride, or it is also called as the acyl chloride. When acyl chloride undergoes reduction, it forms the corresponding aldehyde or ketone. But this reaction is takes place in presence of palladium with the help of barium sulfate. Let's see the reaction. Acyl chloride formula, this one, RC double bond O Cl plus H2. Why H2? Because reduction is given and this reaction is takes place in presence of palladium with barium sulfate as a catalyst. Then see here, the reduction is takes place like this, and this Cl will remove. When the Cl will remove, the addition of hydrogen atom will be here on the carbon atom, and this Cl and this H, it will form the byproduct, that is minus HCl. Okay, you can write this HCl here as a byproduct plus HCl, and when you are writing downside of the arrow, you have to mention with the negative sign the byproduct. Okay, then this will form the H. Okay, this is the general reaction. We will see one example. CH3 C double bond O Cl. Okay, it reacts with hydrogen atom, then it will form acetaldehyde. CH3 C double bond O H plus HCl. See, I have shown byproduct in both the way. Either you can show like this or like this. What is the name of this? It is acetaldehyde. Always remember, you have to write it the main reactant and main product name. This one is the acetyl chloride. Okay, this is what the example what we have seen, and this whole process is called as Roseman reduction. Okay.